Hi, everyone. Thank you so much for joining us today. Welcome to our webinar on using Google Cloud products to build your IoT solutions. It looks like we have a lot of people online, so we're going to go ahead and get started. My name is Isabel. I'm the Director of Marketing here at Leverege. I'll be helping to moderate the webinar today. I'll first note that as we've been testing things out here on our end, we've noticed that there might be a lag once in a while, so just hang tight as we switch slides and remember to reconnect or refresh if you haven't seen a change in a while. With that being said, we're very excited to have you join us today. Again, my name is Isabel. I'll be helping to moderate and answer questions in the chat and things like that. So I'll pass it off to Ryan first.
A few of my colleagues who I will have introduce themselves right now.
Hi, my name is Ita Kwang. I'm the Director of R&D.
Hi, I'm Samir Srivastava. I'm a product engineer.
And I'm Eric Khan, the CEO of Leverege.
Awesome. So today we're going to be sharing what we know and what we've learned about building and scaling IoT solutions with Google Cloud products. For those of you who are not familiar with us, Leverege is an IoT software company and systems integrator that makes a solutions development platform. So we work with companies and clients from startups all the way up to Fortune 500 companies, enabling them to create their own IoT solutions. So you'll be hearing from all of us throughout this webinar, and we'll have a lot of time at the end to answer questions. And if we don't get to your question in the webinar in the time allotted, we will send a follow-up email so you don't miss anything. So now we'll quickly go through the agenda for the webinar. We already went through welcome and introductions. So we're going to start off with how to choose the right IoT cloud platform and key considerations for doing so, why our team chose GCP, an intro to the GCP architecture, and then we will go through a case study using GCP, which is our Siren Marine smart boating application. And then we'll finish up with question and answers from the audience and some questions we received ahead of time as well. So with that being said, I'm going to pass it over to Itek, who will talk about the cloud platform considerations.
All right. Before we get started, can I get a quick poll on the screen to see which cloud platform everyone is currently using? I think it would be interesting to hear the pain points and the success stories with each platform later on during Q&A. So now the most important consideration for choosing a cloud provider is reviewing your IoT use case and matching your business, technical, and operational needs to that use case. Too often, we've seen companies focusing too much on the technical IoT offerings and neglect to review the other components. On the business side, cost and increasingly compliance requirements can help you narrow down the cloud providers to those that meet the regulatory requirements at a price point that makes sense to you. One thing to note here is how sustained use discounts are determined to get an accurate measure of the total cost. Secondly, it's important to consider what managed services and APIs are available. All major providers have at least one IoT-specific feature that may be critical for your use case if you decide not to build your own. For example, AWS IoT has a feature called the device shadow, which represents the last known state of the device. This can be really useful to get the device's values without having to store them yourself or rebuild them from a historical data store. Lastly, operational requirements can drive your cloud provider decision. If your company is already using a Microsoft stack, for example, .NET or C#, sticking with Azure can make the most sense. Also, technical and business support is often overlooked, but existing relationship with these companies can really accelerate growth. And now I'll pass it off to Eric, who can talk about why we chose GCP.
Thanks, Itek. Thought process, and this will be unique to your business, but these were the sort of the guidelines we followed as we ended up selecting GCP. The first one was cost structure, which of course is always very important to any company, trying to minimize your cost structure. As a startup ourselves, and we have many customers in different states of deployment, some of them doing minimum viable products or rapid prototyping, others doing live testing or paid pilots in a region, some of them doing nationwide or even potentially global scaling. We had to look at costs across the whole spectrum of use cases. And so for us, Google made a lot of sense. And some of the things that I'll mention are actually common with some of the other cloud providers, but there were no upfront costs. No termination fees. The majority of providers do not have things like that anyway. But Google has a very interesting pay-as-you-go model where you actually just pay per minute, which is great to have that resolution of payment. We also like that they have sustained use discounts. So you can get up to 30% off automatically of your workloads per month. And that's sort of if you, for instance, left a virtual machine running and you forgot to turn it off, or a part of your business was running longer than you expected, they will automatically apply a 30% discount at the end of the month when they do your credits. You also have the ability to do committed use discounts, where you could sort of lock in discounts up front, and you can build custom machine types to meet your specific needs. And finally, there are price discounts that will automatically kick in if you hit certain thresholds of spending per year or per month. And it's nice to know that they kind of do those automatically. So the second main aspect was security. So while not every cloud platform out there is impervious to hacking or security breaches, there's none that can cover all the bases. Google's probably the closest in our consideration for out of the box security. So they provide complete encryption for data both in motion, as in transit, and at rest, which is a very nice feature. The other thing is they are running, GCP runs on the same exact fiber backbone and infrastructure that Google itself runs on. So everyone is used to relying on Google. It's like the one website you go to when you were trying to check your Wi-Fi connection. So that type of reliability that they've built up over many years is really nice to know that your applications are sitting on the exact same infrastructure. Another thing is compliance, regulatory compliance in particular. So ISO and SOC compliance, which is Sarbanes-Oxley, they have quite a few of those sort of certifications, and we've actually come across a few use cases where especially SOC compliance was really important to the end user. And finally, they have nearly a dozen or more security products that provide all different types of sort of point security solutions, along with endpoints, networks, data, even infrastructure. And another thing that we use is something that's a container vulnerability analysis service that will automatically detect flaws security-wise in our Docker images. Third point is strategy. So this is really a business-specific thing. So for us, partnering with Google was a very, very nice fit strategically. In addition to becoming a technology partner and having all the co-marketing opportunities and lead generation that goes with that, we like the fact that Google is very hungry as a cloud provider, and they're essentially in third place right now, which is kind of a well-known thing behind AWS and Microsoft. But they're very aggressive and committed to becoming one of the top two players in cloud, and we like that as a startup ourselves. We like that kind of go for it mentality, and because they are hungry, they tend to give startups that work with them more opportunities to shine. And so that was just more of a strategic decision on our part. And the final thing is Google's focus as a company on artificial intelligence, or AI, and machine learning. Google just recently announced this week in Google I/O that they're renaming their research department to Google AI. So they are 100% committed to AI, and as most of you probably know, AI and ML is a key driver of automation and efficiency for IoT applications. So those types of features are very critical to us, and Google, we believe, has the lead in AI over the other major players in the market. We regularly use a lot of their APIs for image recognition and cloud ML and other things to accomplish things for our clients. And we also, as a partner of theirs, we get early access to private betas of advanced solutions that they're working on, some of them very specific to certain industries. So for those four reasons, we ended up selecting Google, and we're very, very happy with our choice. At this point, I'm going to hand it back to Itek to kind of walk through a typical architecture within GCP that would be applied to an IoT application. There you go, Itek.
Thank you, Eric. So what you see on the screen is taken from the Google Cloud Platform website. So this is a notional architecture that Google has put together for a typical IoT deployment. So over on the very left, you should see devices. And so these devices could be one device, a bunch of several devices together, or even from a different connectivity provider. And The three that I want to highlight next is Cloud IoT Core, Cloud PubSub, and Cloud Functions. So these three take care of the device management, data ingestion, and related business logic. So Cloud IoT Core is Google's managed service to securely connect and manage devices. So if you do not have a service that is provided by your connectivity partner, this might be a very good tool to use to securely connect devices online. It also natively pumps data via PubSub, which is used. These next three products deal in message processing and storage. Dataflow is a managed instance of Apache Beam. For those of you who do not know what that is, it's a really nice tool to handle stream and batch processing messages at once. You can also pipe those messages to Bigtable for NoSQL options or BigQuery for long-term structured data storage and analysis. And the next product that I want to show is Cloud ML. This is probably the most exciting product listed here. What this is a managed service where you can host your own TensorFlow models and let Google handle all of the server setup. This is really an attractive offering for data analysis and machine learning engineers. So they can just solely focus on training the model and not have to worry about deploying, auto scaling, and setting up the server to handle requests. Finally, on the very right, you have Cloud Data Lab and Cloud Data Studio. Data Lab is a managed instance of Jupyter. So if you're familiar with Python analysis, this could be a good way to collaborate online. And Data Studio is similar to Microsoft's Power BI. You can easily make dashboards that can be shared across different organizations. And now I'll hand it back to Eric, who can talk about our Siren Marine use case.
Great. Thanks, eTech. So we want to try to take some of this technology that we're talking about in sort of components and actually bring it to life with a real use case, something that most of you will understand, especially if there happen to be any boaters on the line here. What we want to do is we want to feature one of our great customers, Siren Marine. They have made a market-defining product that allows you to stay in touch with your boat, essentially. So you can think of it as kind of OnStar for your boat. It's an aftermarket product right now, and you can have it installed or install it yourself, and it will allow you to remotely monitor, manage, and track your boat, which is a very important thing. As you know, boats are very expensive. They're complex systems of systems, and they're unattended most of the time, and that's where the big issue comes. So owners want to maximize their enjoyment on the water, but they don't have insight into the state of their boat before they arrive or what's happening when they're not present, and that presents a lot of emotional and potentially financial distress for them. So the solution is to have what Siren Marine likes to call a connected boat. A boat that you can always reach out and touch, or it will sort of alert you if something happens to it based on rules that you would set. And that's exactly what Siren Marine in concert with Leverege built for the market. So it allows you to provide current location and get battery levels, build settings, and other type of things, even security alerts on your boat through a combination of wired and wireless sensors that get installed either in off-season or you can do it, at the pier. It's a fairly simple installation. You can also set up role-based or user-defined rules for security and boat operations for, say, it goes adrift or you lose shore power due to a storm or someone tries to steal your boat. You can be notified via text messages and everything else. So it's a very powerful peace of mind for a boater at a really good cost. And so what I'd like to do now is hand it off to Samir, who will walk you through, and Samir helped build this application with Siren Marine staff, and he'll kind of walk you through how the system works, one, and also sort of tie it into specific Google products and how we accomplished the various features that you'll see. So here you go, Samir, your turn.
Thank you, Eric. Hi, everyone. I'm Samir, and I'm a product engineer at Leverege. So I'm going to be going over the high-level system overview of the Siren Marine implementation. So start on the left with a boat with a Siren Marine solution. On the boat, there are various critical components to monitor, such as the battery, the high water sensor, and the security sensors. These are really critical because your boat could be sinking or someone could have broken into your boat. So it's important that a boat owner can know this information. So to the right of the boat is the Siren Marine MPC. And the Siren Marine MPC is the brains of the Siren Marine solution. It receives inputs from these various sensors on the boat, and then it will send UDP messages over cellular to the cellular provider containing information about the boat. Then the cellular provider will pass these UDP messages to our platform, and we will unpack these UDP messages as I show you a demo of the Siren Marine implementation solution. Okay, so let me get started setting that up.
All right, and as Samir sets that up, I just want to remind everyone that if you're experiencing a bit of a lag or a glitch every once in a while, just reconnect and you should be getting back up online in just a moment. And if you have any questions while we're going through this demo or any questions that have come up so far, remember to just ask away in the chat and we'll answer them.
Live screen share of an actual iPhone showing the Siren Marine app. So we've made a native Android and iOS app using React Native. So the first thing that we see here is the map on the top of the screen showing where the boat is located. And this is really important for boat owners. It gives the real-time location of the boat, and it really allows them to feel comfortable that their boat is where they think it is, especially because they usually aren't close to their boat, especially during off-season or during the week. It's really on the weekends that they really go to their boat, so it gives them peace of mind to know where their boat is. Additionally, with this GPS feature, we have a position tile. So this tells us where the boat is, and a really cool feature is the geofence. So we have a geofence on the boat. As you can see here, it says enable geofence. So if the boat is a certain distance away from set coordinates, then the boat owner will get an alert. And the amazing thing about the Siren solution is that there's actually edge alerting. So even if the cloud doesn't necessarily detect anything, if the device detects that it's out of the geofence, it actually sends an alert itself over cellular, and we get the alert and then send a text message, email, or even app notification to the user telling them that their boat has left their geofence location, which is really amazing. The second thing I kind of want to show you all is the temperature chart, which really shows data that we're storing using Google products as well. So the temperature is loading in. So this chart is using, has thresholds that can send based off if the temperature is changing from max or min. And then this chart is actually based off Cloud SQL and BigQuery storing data. So we have hourly, daily, and then we also have weekly data of the temperature to show this. So now I'm going to change screens again and show real-time to sync stuff with Firebase.
All right, so just hang tight while we pull that up. We're getting some good questions in the chat that we will definitely get to during the Q&A session.
Okay, so on the left here, I have our Firebase console, and then on the right, I have the screen share again of the live app. So right now, the temperature is about 72.2 degrees Fahrenheit. I'm going to go ahead and change that to 68.5 degrees Fahrenheit. And then, as you can see, the app, the live app actually changed instantaneously. So the really cool thing is that for a boat owner, it means that they can get instantaneous updates.
All right, so that is the live demo of the Siren Marine app, and then Samir is going to walk us through some of the specific products that we use for the solution, the first being Firebase.
Thanks, Isabel. So we're going to start with the first Google product that we're using with the Siren Marine solution. The main one is just Firebase, which really meets our boaters' needs to get their current status of their boat. We're using Firebase's real-time database, and we get pretty instantaneous data storage once we get an update from a device on the boat. And our React Native app listens to Firebase to get these real-time updates. So on the right, there's a diagram showing a backdoor security sensor. So you can imagine this would be useful for someone if they were breaking into their boat. So the first side on the left says the security is okay. And then Firebase, if they receive an alert from the device saying the security sensor has gone off, it changes to an alert state. And it's pretty simple. Security 2 if you see below, changes from false to true on the right side. I'm going to move on to the next two products that we use in our solution. So it's important for boat maintenance and monitoring to store historical information such as engine hours, temperature changes, and security alerts. So in our IoT platform, we store data in two different ways with both BigQuery and Cloud SQL. Cloud SQL is really useful for 30-day historical data. We use it to get pretty quick information. So the charts is mostly using Cloud SQL. And then BigQuery is useful for all-time historical data. And it allows us to do analytics on a large scale. There are other Google products such as Bigtable that also store a lot of data, but BigQuery's cost, low cost, and ability to really store a lot of data steered us towards this solution and this product. And then finally, I'm going to talk about Google Cloud Functions. So to give a bit of background about Cloud Functions are serverless. So most of the application code, the server-side logic is written by the developer. But unlike a traditional server, the developer does not do the DevOps. Instead, Google manages this. So these functions are run in stateless compute containers that are event triggered and fully handle the scaling costs, which is great. And also for something like this application with inconsistent request, scaling is something that Google does really well. So when suppose a security alert goes off, if you break in, once the Cloud Function can handle this load. And the really great thing about the solution for us, because we use Firebase Cloud Functions trigger on Firebase writes. So one of our sensors, wireless sensors, actually don't have edge alerting right now, but is detect writes to Firebase and do cloud alerting. So the wireless sensor can change its temperature into the correct threshold. We can do cloud alerting, detect a write to Firebase, then send the message to the user, and even use Google's Firebase cloud messages for native notifications in both Android and iOS. And the kind of final thing I wanted to do is talk about Siren Marine as a company and application. I've been working closely with Siren Marine for many months, and it's a really great company. So if you all know any boaters or just interested in their application, please visit sirenmarine.com to learn more about their product and their offerings. I'm going to pass it over to Itek now to talk about the Kubernetes architecture for Siren Marine.
Thank you, Samir. So here we have the overall system architecture of the Siren Marine use case, which includes the products that Samir has highlighted before, but also some other system level products like Kubernetes that help with the production deployment. The high level takeaway here is that by using Google services, you can quickly build and augment your core software to build a more scalable systems. One thing to note is that Google components are shown with their corresponding icons, and Leverege specific components such as message processor and transponder are not. And I will walk through each of those components right now. So over on the very left, we have the sensors on the boat communicating to our platform via cellular connection. The first thing that it hits is called message processor, which is something that Leverege has written. And what it does is it maps external IDs, such as Dan's boat or Samir's boat, to internal IDs, and it routes those messages to specific business logic to perform geofencing or other alerting mechanism that Samir has demonstrated earlier. Again, we use Cloud Functions there to only spin up those resources when needed. And we have wrapped that service around something that we like to call reasoners internally. Next, all the messages go through something called transponder. And this is also something that Leverege has written. And what that is that it helps write to all the databases. Again, the real-time database is served by Firebase to update the app, the native app, but also it can also support voice interfaces like Alexa in real time. And all the historical data goes through Cloud SQL and also BigQuery. So in case there's a need for historical data queries such as graphing, then it can also be pushed to the app itself. Finally, as you can see, that most of these are very apt for microservices. And we use Google's managed instance of Kubernetes, which is a container orchestrator that really helps with auto scaling and self-healing. this really reduces your burden on the DevOps and site reliability needs, because Google, with their use of software, can really help with that. On the next slide, what I want to go over quickly is something that we have thought about to increase security with Cloud IoT Core. So currently in the system, what is missing is preventing someone from spoofing the device. What I mean by that is, let's say there's a bad actor that gets access to your boat, and they want to switch out the device that you have installed with the faulty device so they can disable alerts or disable location updates. So currently, with the system that we have, it is really hard to put that hardware security in place. What you have with Cloud IoT Core is that you have the ability to pair the security updates that come with Google with the secure TPM element, for example, like the microchip ATEC series, so you can generate keys on the device itself. The big advantage here is that there are no external communications, so that at no point does the provisioner actually go in there and insert the certificates and the keys. To put it simply, what it does is that the hardware device itself makes the keys, and then now that is being passed to Cloud IoT Core. So you have both hardware security and software security, so you have peace of mind that there is no way that your device has been compromised. So we are looking into this solution in the future to help beef up the security both on the hardware and the software side. And now I'll pass it back to Ryan, who can help moderate the.
Now we're going to open it up and go through some of the questions that were asked in the chat, as well as some questions that came in ahead of time, then pass it around for certain answers. So one question just came in from Riley was if we could give a bit of a detailed breakdown on the cost difference between providers, so AWS, Microsoft's Azure, and then GCP. I think it'd be good to kind of also touch on the difference between the three as well. So I believe, Itak, you want to jump into that?
Yeah. So I think the difference between the three different cloud providers kind of stem from their business model. So Microsoft, they have a huge influence in the enterprise sector. So if you're already using their Office suite or have a .NET or a C# architecture, then it really makes sense to just use the Azure architecture. We initially did begin using Siren Marine on the Azure architecture. However, we found some of the supports to be lacking. For example, Kubernetes wasn't as ready, and some of the AI services that we were likely using for Siren Marine was not ready. And finally, we really liked Firebase, so that was one of the big reasons that we switched over to Google. So speaking of Google, we really respect their AI focus. So some of the implementations that we're looking into the future using their latest deep learning technologies or image recognition capabilities, Google really made sense as a services company. And finally, AWS, as a really great platform company, in fact, they offer the most flexibility in terms of the VMs or the services that you want to use. So if you really have an architecture in mind that you don't really want to use a managed service for, then AWS could be a really great offering, so you can customize and really fine tune for the cost model that makes sense for you.
Cool, thank you. One of the questions that came in from Ming was talking about require statements in HTML embedded JavaScript. Does Google have a plan to support require in HTML embedded JavaScript?
I certainly can't speak for Google, but I think we kind of ran into the same problem. But what we've been doing was kind of using their G-Cloud libraries or their node-specific libraries. So we like to use the Node.js library in the back end. But you can also make direct REST calls, I believe, for some of the functionalities that you might be looking for. So that could be a workaround until Google decides to support HTML versions in the future.
Thanks. Question that came in from Terry. Did you use MQTT for device comms, and if not, why? So Ming reply a little bit to that, but I think we'll add a little bit on our end as well.
For Siren Marine use case, MQTT with IoT Core specifically just didn't exist when we did our use case, but MQTT has existed for a while as a message spec. We didn't use MQTT because the hardware used UDP as the message spec, so that's what we were limited to. It was made by another company called CalAmp, and it really gave Siren Marine all they needed in terms of GPS and other types of functionality. So that's why we ended up using UDP messages.
Great, thanks. Some of the questions we had come in prior to the webinar around this topic we wanted to share as well. One of them was, did you find any pains in migrating? And I think Samir can answer that a little bit as well.
In terms of the migration process, there were definitely things that we had to watch out for in terms of converting our platform to be more ready for Kubernetes and scaling. I think particularly the biggest pain was scaling the UDP messages and load balancing them, but otherwise it was a pretty painless process to get started in Kubernetes in terms of the migration.
Great, and the final question we have at the moment is, can we provide more in-depth into the data encryption feature?
Yeah, so Google has decided that every data that goes into their platform is encrypted by default. So this is a difference from Azure and AWS that, from what I know, that last time I checked. And Google likes to consider all of their networks as one big computer networking system. So whatever goes into a different region is the same. So if you're writing to the database in a central region, that's the same as writing to a database in the eastern region. So they like to encrypt all the data that gets stored and everything that's communicating in between regions. So that's turned on by default, which is a really nice security feature that we encountered so far.
Great. We also had one more question just came through. How much data cleaning was required upon ingest?
There is a good amount of data cleaning. Really depends on which part of the sensor, like what data is coming in. For GPS, there is some data cleaning, which depends on how many satellites we're getting. So if we're not getting a good signal, we won't really update the device and app. If we are, then we will do that. Otherwise, not too much data cleaning on our end. There may be some stuff in the firmware to clean the data, but in terms of what we received, there wasn't a lot of data cleaning for other types of parameters.
Thank you. That pretty much sums up the majority of our questions. If you guys have any more, feel free to shoot them over right now. Other than that, we just want to send everybody who request answers, as well as the slides and full presentation will be sent to you once once we are wrapped up here today. And I also have a 5-day email course completely for free on building solutions with GCP. Highly recommend you sign up for that. You get a new email every day, kind of taking you through the process and all the benefits that we kind of talked about a little bit here today, as well as a deeper dive to help out. So I want to pass it over to Isabel to wrap things up, and thank you guys again.
Yeah, I'll just say thank you again for joining us today. Thank you for engaging and asking questions in the chat. If any questions come up after this webinar, or if you're not watching the webinar live and you do have questions, feel free to shoot them over to us. There will be a way to ask questions after the webinar, and we have our email shared with all of you to do that as well. I really hope we've provided some valuable information to you all as you're building and scaling your own IoT solutions. So I hope you enjoyed the webinar. And like Ryan said, if you are interested in diving a little deeper into these products, the email course, which I will share on the right-hand side of the screen, you can sign up right there. That dives into the products a little bit more in detail if you're interested in learning more. So that pretty much wraps it up for today. Thank you again for joining us, and reach out if you have any questions.